This video explains the project dependency graph which is created and stored using Neo4j GraphDB by the COG server. Let us take the example of the Snakes and Ladders project, which is hosted in the text project repository of GitHub. Let's take a look at the various Java files that exist in this project. This project consists of a package GameBoard, which consists of 4 Java files. It contains a file named ladder.java, which consists of 3 attributes: start position, end position, and color element, and a constructor. Next, there is another file called snake.java, which consists of 3 similar attributes and a corresponding constructor. Further, this project consists of another Java file which is called initializeBoard.java. Let's see this particular file. This particular Java class consists of a method which is called initializeBoard method. This method initializes the board with instances of snake and ladder objects. And finally, there is a class named setGainForPlay.java, which has a method drawBoard, which this method creates an instance of the initializeBoard class and then invokes the initBoard method of the initializeBoard class. Now, this is my COG server which I have already started. Now let's have a look as to how we use the COG server to clone the remote project repository and create the project dependency graph. This particular folder within the Eclipse folder, which is Neo4jDB, which is currently empty, this is the place where the project dependency graph would be created. Now I will invoke the admin module of the COG, which is used to create the dependency graph. This is the COG admin module which is used for configuring the project and create the project dependency graph. Here we need to enter certain information. This is the name of the project which has to be cloned. This should be the same as the name of the project on GitHub. Then this is the owner name. Then this is the repository URL which has to be cloned. I have pre-filled this information. You can see here this shows Ritu Arora bits test project repo.git. Then these 2 fields store information related to certain temporary folders where the clone of the project will be created in my system and which will be used to create the project dependency graph. Now I use this admin module to configure the project. I get a message that the project graph has been created successfully. Let's see at the server side. We get certain messages which inform us about creation of the database. Now let's go back to this Neo4jDB folder. We find that a server has been created here. And if we go inside this folder, we see that the Neo4j Graph database of the project dependency graph has been created. Now let us invoke the UI of the Neo4j DB in order to view this project dependency graph. I choose the graph that has been created inside the Eclipse Neo4j folder. So this is the server, this is the same folder that I am accessing here, and I open this folder and then I say start. Now this will give me a URL to this particular DB. Now using this URL, I invoke the Neo4j UI. It gives me the default password is Neo4j. I connect to the server, enter a password, reconfirm the password, and I set the password. Now I am logged into the server. Now I use this particular option to give me the information. I press star here, and this is the project dependency graph which gets displayed. Here you can see that there are 7 types of nodes which are created. In this, since there is no interface node, hence there is no such node created, so there are only 6 types of nodes, plus there are 3 types of edges that exist in this graph. Now let's see this graph. It provides a colored visualization of the project dependency graph. So you can see that the project node is colored gray. This is my project node. Let me drag and fix it here. Then there is the package node which is purple. So this is my package node which is here. Then my class nodes are colored red. So I drag the class nodes and fix them at a particular place so that I am able to easily visualize them, right? So this is my snake class. It has 3 attributes which are blue in color, and it has one constructor which is a method, so which is the yellow colored node. Then I have a ladder class which also has a constructor and 3 attribute nodes which are blue in color. Then there is a initialize board class which has a method init board, and the init board method has 2 method attributes, S, L, L and S. These 2 attributes are of snake and ladder objects. Now my set game for play class, which is also red in color, has a method draw board. Let me fix it here. And this method draw board has a method attribute which is the board. Right. So now you can see that all these nodes are connected to each other either through connecting edges or dependency edges or body edges. Body edges are the ones which connect a method attribute to its method. Now let us visualize a few of the dependency edges. In the initialize board class, the init board method let's come here. The set game for play class has a method draw board which creates an object of the initialize board. So there is a uses dependency edge from the draw board to the initialize board class. Then this method also invokes the init board method. So there is a calls edge from the draw board to the init board method. Now further, this init board method creates instances of snakes and ladders object. So there is a uses relationship between the init board method and the snake class, and the init board method and the ladder class. Right. So this is the complete dependency graph of the snakes and ladders project. Further, we can also see that the properties associated with every node and edge gets displayed here. So there is a detailing of the properties of every node and every edge. So if we click a node, then this particular bar details the various properties that are associated with that particular node or the particular edge. Thank you.